Welcome to the Deep Dive, where we extract the most important nuggets of knowledge from a stack of sources, giving you a shortcut to being truly well-informed. Today, we're plunging into a topic that is absolutely foundational. For every business, every individual, really, who cherishes their digital life. We're talking about the art and science of protecting our invaluable data.
That's right. It's something maybe you don't think about every single day, but it's always there, working behind the scenes.
Yeah.
Behind every successful online transaction, every saved document, every photo you take, there's hopefully a silent guardian at work.
Data backup.
Exactly.
So our mission today is, well, it's a crucial one. We're going to act as your guides, kind of help you understand the core concepts of data backup. We'll explore how these technologies have evolved over time, which is pretty fascinating in itself.
Yeah.
And then, and this is the key part, we'll take all this knowledge and apply it. Apply it to a real-world scenario.
Yeah, think of it like a case study, a deep dive into data resilience. We'll look at common pitfalls, things that go wrong, but also highlight the most modern, robust solutions available today.
Our goal is for you to walk away with clear, actionable insights. Understanding how organizations really safeguard their digital assets in this, well, fast-paced, always-on world we live in.
Okay, so let's start right at the beginning. The foundational why. Why are backups not just, a good idea, but an absolute non-negotiable for any organization?
It's easy to think of them just for, like, oops, I deleted a file.
Right. We've all been there. But they serve really three critical purposes that go way beyond that simple mishap. These aren't just, IT jargon. They're fundamental pillars. Pillars for business survival, for continuity, especially when facing digital threats.
Missing any one of them.
Yeah.
It sounds like building a house without a roof.
Pretty much, yeah. You're exposed.
So what's the first pillar?
First, we have disaster recovery. Big one. This is all about enabling the restoration of operations, but at an alternate site. This kicks in when a primary location is just incapacitated, taken out by some unforeseen event.
Like the really major stuff, floods, fires.
Exactly. Natural disasters, floods, fires, earthquakes, or even things like large-scale power outages, or increasingly widespread cyber attacks that cripple a main site. When your main data center is physically compromised, maybe completely offline, backups are your lifeline. They let you bring everything back online somewhere else.
Maybe a remote recovery site.
Precisely. Ensuring your business can actually continue to function. It's about surviving that big catastrophic hit. Although what's truly fascinating here is, while we often imagine those huge catastrophes, statistically, major disasters account for less than 1% of information unavailability.
Less than 1%, really?
The vast majority of outages are actually planned.
Planned? Like what?
Things like software upgrades, routine system maintenance. Even the backup process itself sometimes requires downtime. But here's the thing. Even planned outages cause data to be unavailable, and that incurs costs.
Oh, okay. Makes sense.
So while disaster recovery is absolutely vital for those rare, large-scale events, data protection is equally crucial for both planned and unplanned scenarios. Doesn't matter the scale.
That's a really great distinction. And it leads us perfectly into the second pillar, which you hinted is maybe the most common reason.
Definitely the most common need. That's operational recovery.
Okay, so day-to-day stuff.
Exactly. This is about recovering from the everyday mishaps. The kind of incidents most organizations deal with, well, daily or certainly very regularly. We're talking about accidental data deletion. A user deletes an important email, maybe empties their trash.
Done that.
Or logical corruption. Maybe a critical spreadsheet gets garbled during a save right before a big deadline.
Oh, nightmare scenario.
These are those daily incidents that backups are designed to quickly resolve. They prevent loss of productivity, ensure business continuity, without major disruption, keeping the day-to-day operations smooth.
That makes a lot of sense. These granular common incidents are probably what drive most restore requests then.
They absolutely do. In most places, yeah. Being able to quickly recover from such routine issues is paramount because the cost of unavailability, even for just a short period, can be genuinely staggering, especially for businesses operating in that on-command, on-demand world.
Every minute counts.
Every minute of lost productivity translates directly to lost revenue or missed opportunities. It adds up fast.
Okay, so we've got disaster recovery for the big hits, operational recovery for the daily stumbles. What's the third pillar?
The third one is archival.
Archival. So this isn't about fixing a recent mistake.
Not directly, no. This is about the long-term preservation of historical data. Think keeping records for years, even decades. This is often driven by, strict regulatory compliance requirements. Think finance, healthcare.
Right. Legal obligations, maybe.
Absolutely. Legal holds, e-discovery, or even just long-term business intelligence needs, like transaction records that need to be kept for 7 years by law, email messages that must be auditable for a decade, critical design documents for the entire life cycle of a product.
So backups handle this too.
Traditional backups can play a role here, yeah, especially for, say, small to medium-sized businesses. But it's worth noting,
Yes.
more modern solutions like content address storage or CAS have really emerged as primary solutions for archiving large volumes of fixed content, stuff that doesn't change.
How does CAS work, briefly?
While CAS stores and retrieves data based on its unique content, like a fingerprint, rather than a traditional file path, this means it automatically eliminates duplicates and helps ensure data integrity over very long periods, really efficient for long-term holds.
Interesting. But the goal for archival, whether backup or CAS, is retaining data for years, ensuring it's safe and accessible for future reference or audit, even if you almost never look at it.
That's the essence of it, yes. Integrity and accessibility over the long haul.
Okay, so those three pillars: disaster recovery, operational recovery, archival, they really cover the basis.
They do. And if we connect all these purposes to the bigger picture, they bring us to a really critical concept in backup operations: the backup window.
The backup window,
Yeah.
right. I've heard that term. What exactly is it?
It's simply the defined period during which your production data is actually available for backup operations. Think of it as the time slot when your systems can tolerate the extra resource strain, or maybe even a brief downtime that's required for data protection.
And minimizing this window is key.
Absolutely crucial, especially for continuous business operations and meeting those high availability demands of today's 24/7 world. Just imagine if your critical online services, your e-commerce site, your financial trading systems, imagine they had to be shut down for hours every night just for a backup.
Unthinkable for most businesses today.
Exactly. It's just not feasible, particularly in sectors like financial services or telecommunications, where unavailability can literally cost millions of dollars per hour.
Wow.
So the shorter the backup window, the less impact on your operations and the more resilient your business ultimately remains.
Okay, so now that we understand why backups are so critical, let's explore how they're actually done. Because it's not just one button, is it?
Definitely not. When you get into the technicalities, you realize organizations strategically choose from different types of backups, and each type impacts two key things: recovery time, how fast you can get your data back.
Which is obviously important.
Crucial. And storage consumption, how much space those backups actually take up.
Which costs money and resources.
Precisely. So choosing among these isn't just about how you copy data. It's a fundamental decision. It directly impacts how much data you can afford to potentially lose. That's your recovery point objective, your RPO.
Okay.
And how quickly you can get back online after something goes wrong, your recovery time objective, or RTO.
RPO and RTO. Got it. So it's always a balancing act.
Always a balance.
Yeah.
Speed versus resources versus risk.
Okay, let's break down the types. What's the first one?
First up, the most straightforward, the full backup.
Sounds simple enough.
It is. It's
Yeah.
exactly what it sounds like: a complete replication, a full copy of all the data on your production volumes at that point in time.
So the biggest benefit here must be recovery speed.
Absolutely. It provides the fastest possible recovery time. Why? Because you only need that one single copy to restore your data.
Makes sense. If you have Monday's full backup, you just restore Monday's full backup, and you're back to how things were on Monday.
Exactly. Restore that one copy and you're done. Simple.
But there's always a but, right? What are the drawbacks?
The drawbacks are significant, yeah. First, it requires the most storage space. You're copying everything every time.
Okay.
And second, it takes the longest time to complete, which, as we just discussed, directly impacts that all-important backup window.
Making it challenging for systems that need to be online constantly.
Very challenging. That's precisely why organizations rarely rely solely on full backups for everything, every day. While they offer the simplest recovery, the demands they place on storage in that backup window are often just prohibitive for daily use in a dynamic environment.
So they mix and match.
Usually, yes. They combine it with other methods to balance efficiency and recovery speed.
Which brings us to the next type.
Right. Incremental backup. This is where things get a bit more clever and definitely more efficient in terms of backup time and space.
Okay. How does incremental work?
An incremental backup copies only the data that has changed since the last backup, whether that last backup was a full or another incremental, whichever happened more recently.
Okay, so only the delta, the difference since the very last operation.
Precisely. So if you did a full backup on Monday night,
Yep.
Tuesday night's incremental only copies what changed between Monday night and Tuesday night.
And Wednesday's incremental.
Only copies what changed between Tuesday night and Wednesday night, just the latest changes.
The benefit seems obvious.
Yeah.
Much faster backups.
Hugely faster backup operations, yeah. Because the volume of data being copied is typically much, much smaller. That means less network bandwidth consumed, less storage space used during the backup process.
But I sense another trade-off coming. What's the catch with incremental?
The trade-off is complexity and time during restoration. The restoration process with incremental backups is inherently more complex and definitely more time-consuming. To fully recover your data to a specific point in time, you need the last full backup.
Okay, the baseline.
PLUS, all subsequent incremental backups applied in sequential order right up to the desired point of restoration.
So it's like stacking building blocks. You need the foundation and every single block added since then in the right order.
Exactly. It's like putting together a multi-piece puzzle where each piece depends on the one before it.
Let's walk through that example you mentioned to make it really clear.
Good idea. Okay, imagine. Full backup on Monday evening.
Got it.
On Tuesday, maybe a user adds a new file, file 4. Tuesday's incremental backup copies only file 4.
Small, fast backup.
Right. On Wednesday, maybe file 3 gets modified. Wednesday's incremental copies only that modified file 3.
Okay.
On Thursday, a new file 5 is added. Thursday's incremental copies only file 5.
Still small, quick backups each night.
Correct. Now, disaster strikes Friday morning. Data corruption. You need to recover everything back to how it was Thursday evening.
Okay, what do I need?
First, you restore Monday's full backup. That's your base.
Right.
Then you have to apply Tuesday's incremental, then Wednesday's incremental, and finally Thursday's incremental, all in that precise sequence.
Wow. That sounds like it could take a while, especially if you have daily incrementals for a whole week.
It can. And it also introduces more points of failure if just one of those incremental backups is corrupted or missing.
You can't get fully back to that point in time?
Exactly. Your recovery chain is broken.
So to simplify that restoration complexity, there must be another way.
There is. It's called cumulative backup, though you'll often hear it called a differential backup. They mean the same thing.
Okay, cumulative or differential. How is it different from incremental?
A cumulative backup copies all the data that has changed since the last full backup.
Not since the last backup, but since the last full backup.
Precisely. It doesn't just look at the changes from yesterday, it looks all the way back to the last full one. Each cumulative backup contains all the changes made since that most recent full backup.
Okay, I think I see the benefit. Faster restores.
Much faster to restore compared to incrementals, yes, that's the main advantage. For a full restoration, you only need 2 pieces. The last full backup and the latest cumulative backup.
Just 2. The full and the very last cumulative.
It's it. It simplifies the recovery process significantly. You're not juggling potentially dozens of incremental sets.
That sounds much less error-prone, too.
It generally is. But of course, there's a trade-off on the backup side.
Let me guess. The backups themselves take longer than incrementals.
You got it. The backup time for a cumulative will increase over the course of the week. Why? Because more and more data accumulates since the last full backup was taken. So each night's cumulative copies more data than the night before.
So slower to back up than an incremental, because it copies more data each time.
Correct.
But significantly faster to restore.
Exactly. That's the balance.
Let's use our file example again for cumulative, just to see the difference clearly.
Okay. Monday evening. Full backup.
Done.
Tuesday, file 4 is added. Tuesday's cumulative copies file 4. Same as incremental so far.
Right.
Now Wednesday, file 5 is added. Wednesday's cumulative backup copies. What do you think?
Since it's cumulative since Monday, it copies file 4 and file 5.
Bingo. It copies both file 4 and file 5 because both have changed since Monday's full backup.
Okay, getting bigger.
Yep. Thursday, file 6 is added.
Yep.
Thursday's cumulative copies file 4, file 5, and file 6 again. Everything that has changed since Monday's full.
So that Thursday cumulative is the biggest one of the week, besides the full.
Correct. Now, corruption hits Friday morning. You need to restore to Thursday evening. What do you grab?
Okay, based on what you said, Monday's full backup.
Yep.
And then only Thursday's cumulative backup.
That's it. Restore the full, apply the latest cumulative, and you're done.
Wow.
Much simpler.
Way simpler. Cuts down the steps, reduces the chance of something going wrong during the restore.
It really highlights why understanding these nuances, full, incremental, cumulative, is absolutely critical for businesses. They have to design backup strategies that meet their specific recovery point objective, RPO, and recovery time objective, RTO requirements.
If your RTO is super tight, you need to be back online in minutes.
Then, solutions offering faster recovery, like fulls or cumulatives, might be preferred, even if they need more backup time or storage.
Conversely, if your backup window is the main constraint, but your RTO is a bit more flexible,
Then maybe an incremental strategy makes more sense because the daily backups are faster.
it's always that fundamental trade-off in data protection. Speed of backup versus speed of recovery.
You nailed it.
All right, so we've covered the why, the critical need for backups, and the what, the different types like full, incremental, cumulative. Now let's unpack the how. Let's look under the hood at the architecture. Because as you said, a backup isn't just a simple copy command.
Not at all. It's a carefully orchestrated process. It involves several specialized components all working together in harmony. Think of it like a finely tuned machine, maybe an assembly line, where each part has its own crucial role, all aimed at ensuring data is safely copied and, just as importantly, can be reliably restored later.
Okay, so what are these core components? Lay out the machine parts for us.
At the heart of it, we typically have 4 core components interacting. First, the backup client.
The source.
Exactly. The source system could be a server, a desktop, an application host, and it's running a specialized piece of software, a backup agent. Its job is to gather the data that needs backing up, package it up, maybe compress it, and prepare it for transport.
Got it. Client prepares the data. What's next?
Then there's the backup server. This is the brains of the operation, the central control unit. It initiates backups, it coordinates everything, manages the whole environment, and crucially,
Yes.
it maintains a vital backup catalog. Think of this like a detailed library card catalog or a database index for all your backups.
So it knows exactly what was backed up, when, from where, and where it's stored.
Precisely. It's the roadmap.
Yeah.
Without it, finding specific data for a restore would be incredibly difficult, maybe impossible.
Okay. Client, server. What else?
Next, we have the storage node. You might also hear this called a media server. This is a host system that controls the actual physical backup devices. Its main job is writing the data to the chosen media, whether that's tape or disk or something else.
Does it have to be a separate machine?
Not always. In many cases, especially in smaller setups, the storage node functionality is integrated right into the backup server. Same box, doing both jobs.
Okay. And the final piece.
The backup device itself, this is the target hardware.
Yep.
The physical destination where the backup data is persistently stored. Could be an old school tape drive in a library, could be a modern disk array, maybe a virtual tape library. That's where the data lands.
Client, server, storage node, device. Makes sense. So how do they all work together? What's the workflow?
Right, the workflow is like a coordinated dance between these components. It ensures efficiency, accuracy. It typically starts with initiation. The backup server kicks off the process based on schedules you've pre-configured. Like, okay, Group A client, start your backup at 3 a.m. daily.
Automated.
Ideally, yes. Then comes the instruction flow. The backup server consults its catalog, and maybe it needs to know which tape to use or which disk volume has space. It instructs the storage node to load the appropriate backup media into the backup device, get ready to receive data. And simultaneously, it instructs the relevant backup clients. Okay, gather your designated data now.
So the server is the conductor, telling everyone what to do.
Exactly. Next, the actual data movement. The clients start sending the data they've gathered over the network to the storage node they were assigned.
And while that's happening,
While the data is flowing, the client also sends backup metadata back to the backup server. Details like, the number of files, the names of the files, which storage node it's talking to, information for the catalog.
okay, data goes client to storage node, metadata goes client to server.
Right. Meanwhile, data organization and storage happens at the storage node. It receives the data streams from the clients, it organizes the data according to the backup policy, maybe multiplexing streams, and then sends it to the actual backup device for persistent storage. Writing it down.
And the storage node also talks to the server.
It does. Once the data is written, the storage node sends its own batch of metadata to the backup server. This includes things like the exact location of the data on the backup media, like tape block number or disk location, the precise time the backup finished, more details for the catalog.
And the final step.
The crucial catalog update. The backup server takes all this metadata from the client, from the storage node, and updates its comprehensive catalog. This ensures the catalog is always current, always accurate. It's the definitive roadmap for any future restorations.
Because without that catalog,
You're flying blind. Finding specific files or specific point-in-time recovery would be a nightmare.
which brings us perfectly to the most important part, the restoration imperative, bringing data back.
Exactly, because let's be honest, a backup is utterly useless if you can't restore from it when you desperately need to.
So how does restore typically start?
A restore process is usually initiated manually. An administrator, maybe responding to a user request or an outage, uses the backup software, often from the client machine needing the restore.
Okay, they use a restore application.
Right. And through that application, they can browse the backup catalog. They view the list of backed up clients. They select the specific data they need to restore, maybe a file, a folder, a whole database. They identify the target client for the restoration, usually the same client, but maybe a different one. And crucially, they select the specific point in time, the RPO, they want to recover from, based on what the catalog shows is available.
So the catalog is just as critical for restore as it is for backup.
Absolutely, it guides the whole process.
Then what happens? Data flow in reverse.
Pretty much. The backup server, having identified the correct data and its location from the catalog, instructs the appropriate storage node, mount this specific tape, or access this disk volume. The data is then read from that backup media by the storage node and sent back over the network to the identified client system where it needs to be restored.
And the speed and success of this phase is really the ultimate test of your backup strategy.
It really is. Your RTO lives or dies here.
Now, you mentioned databases earlier. Is restoring them trickier?
It can be, yeah. This raises important consistency concerns. While restoring a single file, like a spreadsheet, is often straightforward.
Yeah, just overwrite the old one or restore it alongside.
Right. But in database restorations, it's usually not enough to just restore the main database files. Additional data, specifically things like transaction log files, must often be restored along with the production data.
Why is that?
To ensure consistency. It makes sure the restored database is in a usable, coherent state, reflecting all completed transactions right up to the point of recovery. You don't want half-finished transactions causing corruption.
And that takes extra time.
It often extends the recovery time objective, the RTO, sometimes significantly, because you have these additional steps, restoring logs, maybe replaying them, verifying the database consistency. It adds complexity.
Okay, that's crucial for applications. But what about the server itself, especially in a disaster?
Great point. Protecting server configurations is another vital but sometimes overlooked aspect for swift recovery. Think about a true disaster recovery scenario. Your building is gone, you're setting up in a cold site. Just restoring your application data isn't enough, is it?
No, you need a server to restore it to.
Exactly. You first need a functional server environment. Recreating those server configurations, the operating system install, all the patches, the installed applications, specific server settings, registry keys. Doing all of that before the application data can even be accessed is a critical and potentially very time-consuming step.
So how do you speed that up?
This is where Server Configuration Backup, or SCB, comes in. Specialized tools or features within backup software that create and back up these server configuration profiles, usually on a defined schedule.
And the benefit?
The key benefit is that these backed up profiles can be used to configure a recovery server quickly. Even, and this is really powerful, enabling recovery onto dissimilar hardware.
Dissimilar hardware, so you don't need the exact same server model.
Often, yes. The SCB tools can adapt the configuration. This is absolutely vital for rapid restoration and ensuring business continuity. It lets you quickly stand up a functional server platform ready to receive its application data, dramatically cutting down your overall RTO. Gets the foundation built fast. #DD. Strategic considerations for backup.
Wow, okay. There's a lot more going on here than just copying files. So putting it all together, what does this mean for you, the listener? For your organization's data strategy? Beyond the mechanics, the components, there are several key factors that really shape your overall backup strategy, right?
Absolutely. It's not just about picking a technology off the shelf. It's about designing a system, a process that aligns precisely with your specific business needs, your risk tolerance, your budget. It's about making informed choices.
And you mentioned two acronyms earlier that seem central, RPO and RTO.
They are the primary drivers, absolutely number 1 and 2. Your recovery point objective, or RPO, dictates how much data loss your business can tolerate. That, in turn, determines your required backup frequency. For instance, if your RPO is 1 day, meaning you can only afford to lose up to 1 day's worth of data, well, you need to be backing up that data at least daily. If it's 1 hour, you need hourly backups or maybe even continuous data protection.
Makes sense. And RTO?
Your recovery time objective, or RTO, defines the maximum acceptable amount of downtime your business can endure after something goes wrong. How long can you afford to be offline? This heavily impacts the chosen recovery technology and often the cost. If you need to be up and running again in minutes, you'll need very different, often more expensive solutions, maybe high availability clustering, faster backup media, automated recovery processes.
Compared to a business that can maybe tolerate a few hours of downtime.
Exactly. Their technology choices might be different, potentially less costly. RPO and RTO set the goalpost for everything else.
Okay, what other factors come into play?
Well, there's the retention period. How long do you actually need to keep those backup copies? This is often driven by external forces like strict regulatory compliance, think IPA, SOX, GDPR, legal hold requirements for potential lawsuits, or maybe internal auditing policies.
So data might need to be kept for weeks, months, years.
Or even decades in some cases. Weeks for operational recovery, maybe 7 years for financial records, potentially forever for certain historical archives. This impacts your storage capacity needs significantly.
And the choice of backup media type, the target, that matters too.
Hugely. As we've touched on, it directly impacts your data recovery time, your RTO. Are you using older, slower sequential tapes? Or modern, fast, random access disk drives? Or maybe cloud storage? Each has different speed characteristics.
And then there's the granularity choice we detailed earlier.
Right. Your choice between full, incremental, or cumulative backups. As we saw, that directly impacts both your backup window duration and your restoration speed. You're constantly balancing efficiency during backup with speed during recovery.
The backup window itself remains a crucial consideration too. You emphasize that.
Absolutely. The goal is always to minimize disruption to production operations, keep the business running smoothly while protection happens in the background as much as possible.
What about the data itself? Do its characteristics matter?
They do, significantly. The data characteristics, specifically the size and number of files you're backing up, impact the speed and efficiency. Here's a slightly counterintuitive point. Backing up a few large-size files, say 10 1MB files totaling 10 MB, actually takes less time.
Less time.
Compared to backing up an equal amount of data, 10 MB, but composed of many small-size files, like, say, 10,000 1KB files.
Why is that?
It's down to overhead. The backup system has to perform more operations, opening the file, reading metadata, writing metadata, closing the file for each individual file. Doing that 10,000 times takes longer than doing it 10 times, even if the total data volume is the same.
Interesting. So lots of tiny files can slow things down disproportionately.
They can. To combat this, and just generally improve efficiency, data compression and deduplication technologies are now widely used in backup environments.
We'll dig into deduplication more later, but compression is just shrinking the data?
Essentially, yes. Making it smaller before sending or storing it. Both compression and deduplication are instrumental. They save space on the backup media, obviously. But critically, they also help reduce the backup window by minimizing the amount of data that needs to be transferred over the network and written to the target device. Makes the whole process faster and more efficient.
And finally, you mentioned location, especially for bigger companies.
Yeah, a huge factor for many large organizations. They often operate across dozens of different systems, heterogeneous platforms, different operating systems, different applications. And these systems might be local in a central data center or spread across various remote offices or even cloud environments.
So the backup strategy needs to cover all of that.
It has to. Your backup process must be able to address all these diverse sources, ensuring transactional integrity for databases, content integrity for files, no matter where that data resides. It's about protecting data consistently across the entire distributed enterprise, ensuring geographically dispersed teams can still recover their critical information quickly and reliably when needed. Okay, so moving beyond the core components and those strategic what-ifs, let's explore how the actual physical and logical connections, the layout, defines backup efficiency. The topology of your backup infrastructure, how everything is wired together, was a really significant impact on performance, scalability, manageability. It directly influences how quickly data moves from its source to its protected destination.
Makes sense. The plumbing matters. So what are the common ways to set this up?
Well, the simplest, perhaps oldest approach is direct attach to backup.
Direct attach, like plugging a USB drive into a laptop.
Kind of, but on a server scale. In this setup, the storage node software runs directly on the backup client, the server being backed up, and the backup device, maybe a tape drive or a small disk array, is physically plugged right into that server.
Okay, so the data doesn't go far.
Exactly. The main advantage is it frees up your main local area network, the LAN, from all that heavy backup data traffic. Only the control information, the metadata, needs to go over the LAN to the central backup server. The actual data movement is local, server to device.
It sounds good for network performance. What's the downside?
Its limitation becomes really apparent as your environment scales up. It lacks centralized management. Each server's backup is kind of managed individually, and sharing those backup devices among multiple servers isn't really optimized or even possible sometimes.
So every server might need its own tape drive.
Potentially, yeah, which leads to much higher costs as the environment grows. It becomes inefficient and hard to manage for larger, more complex setups.
Okay, so if you've got lots of servers, direct attached gets expensive and messy fast. What's next?
That usually leads organizations to LAN-based backup. This is probably what many listeners might be most familiar with, especially in smaller to medium businesses.
How does this one work?
Here, all the components the client's needing backup, the central backup server, the storage node, which might be on the backup server, and the backup device itself are all connected to the main local area network, the LAN.
Everything on the same network. Advantage, simplicity, central control.
Exactly. Simpler setup, easier centralized management. The challenge, as you might guess,
Network traffic.
bingo. The actual data being backed up is transferred directly over that shared LAN, which, as the source material says, might affect network performance.
Especially during peak backup times, or if the network is already busy with production work.
Precisely. Large backup jobs can slow down your production traffic, impacting users and applications.
So how do companies deal with that?
There are ways to mitigate the impact. One common strategy is to configure separate networks, or at least separate VLANs, dedicated solely for backup traffic. Creates an isolated path so backup doesn't contend directly with production stuff.
Okay, a dedicated backup highway.
Kind of, yeah. Another approach is installing dedicated storage nodes for specific high-volume application servers or departments. This helps isolate the traffic and offloads the main network.
But it's still fundamentally using the LAN for data transfer.
It is, which is why, for true scalability and efficiency, especially in larger performance-intensive environments, SAN-based backup, often called LAN-free backup, is frequently the preferred solution.
Okay, SAN-based LAN-free. How does this avoid the LAN?
In this topology, the backup device, like a large tape library or disk array, and the clients, the servers being backed up, are both attached to a storage area network, or SAN.
A SAN. That's a separate network just for storage traffic.
Yeah.
Right. High speed.
Exactly. A dedicated high-speed network, usually fiber channel or ISCSI, primarily used for block-level storage access between servers and storage arrays. What's ingenious here is that this becomes, as the material states, the most appropriate solution when a backup device needs to be shared among clients.
Why? Because the data moves over the SAN.
Precisely. The actual backup data traffic is restricted entirely to the SAN. It completely bypasses your main corporate LAN. Only the backup metadata, the control commands, the catalog updates, is transported over the LAN between the client storage node and the backup server.
And metadata volume is small compared to the actual data.
Insignificant, usually. So your LAN performance is not degraded at all during those heavy backup operations. It stays free for production traffic.
That sounds like a huge advantage.
It is. It enables really efficient sharing of potentially expensive backup devices among many clients, improving resource utilization and cutting hardware costs in the long run. It also really facilitates using low-cost disks as a backup medium by attaching large disk arrays directly to the SAN. Makes disk backup very scalable.
And you could still use tapes with this.
Absolutely. Tapes can then be used, perhaps attached to the same SAN, or maybe via a gateway, for the next tier, like off-site disaster recovery copies of those primary disk-based backups. Creates a robust tiered strategy. Speed on disk, low-cost retention on tape.
Optimizing for both speed and cost effectiveness.
Nice. Is there a middle ground?
Sometimes, yeah. Organizations might opt for a mixed topology.
Makes sense, using both LAN and SAN.
Exactly. As the name suggests, it's a pragmatic approach that uses both the LAN-based and SAN-based topologies within the same overall environment.
Why would they do that? Seems complex.
Well, it's typically implemented for a blend of reasons. Could be cost, server location, reduction in administrative overhead, and performance considerations. For instance, a company might use high-performance SAN-based backup for their critical high-volume databases in the main data center.
Where speed and isolation are paramount. Right. But they might opt for simpler, cheaper, LAN-based backup for smaller, less critical departmental file servers, maybe in remote offices where building out a SAN isn't feasible or cost-effective.
So it's about finding the right tool for the right job within a diverse infrastructure.
Exactly. A practical balance of efficiency, cost, and performance tailored to different needs within the organization.
Okay, we've covered general server backups and how the network topology impacts them. But what about network-attached storage, or NAS? You mentioned earlier that backing up NAS devices has its own unique wrinkles.
It absolutely does. Here's where it gets particularly interesting, because NAS devices aren't just standard servers. They present their own set of challenges and require specialized solutions for backup.
Why are they so different?
Well, the NAS conundrum, as the material puts it, lies in a couple of things. First, the NAS heads, the controllers that actually provide the network file sharing, typically run proprietary, often stripped-down operating systems and use specialized internal file system structures. At the same time, their job is to support multiple standard file sharing protocols simultaneously, like CIFS, which Windows clients use, and NFS, which Linux clients use.
Okay, so they're specialized appliances, not general-purpose servers.
Right. And this combination means you usually can't just install a standard backup agent directly onto the NAS head like you would on a Windows or Linux server. There's often no place or way to install it.
Ah, so the usual client-agent approach doesn't work easily.
Exactly. This inherently requires specialized backup approaches that differ quite a bit from traditional server backups.
So how do you back up a NAS then? What are the methods?
One approach is called application server-based backup, or sometimes just client-based NAS backup.
How does that work? Sounds like it involves another server.
It does. In this workflow, the NAS head retrieves the data that needs backing up. Then, it transfers that data over the network to a backup client agent running on a separate application server. That application server then acts like a regular backup client, sending the data it received from the NAS, again over the network, to a storage node, which finally writes it to the backup device.
That sounds inefficient. Data goes NAS to server to storage node. Lots of network hops.
Exactly. The major drawbacks are significant. It results in overloading the network with the backup data because the data traverses the LAN twice, essentially. And it uses up valuable CPU and memory resources on your application server just to move the backup data around. That adds a substantial unnecessary burden.
Slows down production apps, potentially.
Potentially, yes. Not ideal.
Okay, so how do you avoid that network congestion and resource drain on the app server?
There's a more efficient method known as serverless backup. Despite the name, there are still servers involved, but the application server is taken out of the data path.
How does serverless work then?
With this approach, the network file share from the NAS head is mounted directly on the storage node itself.
Ah, so the storage node connects directly to the NAS share.
Right. Instead of data going through an intermediary application server, the backup data moves directly from the NAS across the network to the storage node. The huge advantage here is it avoids overloading that production network twice and completely eliminates the need to use resources on the application server during the backup. It effectively eliminates one network hop, streamlining the data flow.
So the storage node acts as the backup client in this case. Reads from NAS, writes to its device.
Precisely. Reads data directly from the NAS share and writes it to its attached or assigned backup device. Much more efficient.
That sounds better. Is there an even more optimized way, maybe an industry standard?
There is, and it's often the most efficient and robust solution, especially for larger NAS environments. It's the Network Data Management Protocol, or NDMP.
NDMP. Okay, what is that?
It's an industry standard TCP/IP-based protocol specifically designed for backup in a NAS environment. Its whole purpose is to allow direct, optimized communication between the NAS heads themselves, the backup devices attached to them, and the central backup server for coordinating the process.
So it lets the NAS talk directly to the backup gear.
Essentially, yes. The benefits are significant. It enables data to be backed up regardless of the specific proprietary OS or platform of the NAS device. It also reduces the load on the application server and improves the backup speed, because the bulk data doesn't have to be transported through an application server at all.
Where does the data go then?
Crucially, NDMP optimizes backup and restore by leveraging the high-speed connection between the backup devices and the NAS head. The heavy lifting, the actual backup data, ideally goes directly from the NAS head straight to a backup device, often locally attached or attached via a dedicated network SN. Meanwhile, the metadata, file lists, status is sent over the regular network to the backup server for cataloging and control.
Data path optimized, control path separate. Makes sense.
Maximizes efficiency, minimizes impact on the production LAN.
Are there different ways NDMP works?
Yes, within NDMP, there are two common implementations, often called ways, based on how devices are connected and shared. First is NDMP two-way. In this setup, data from the NAS head goes directly to a backup device that is locally attached to that specific NAS head.
So NAS box talks to its own tape drive directly.
Pretty much, yes. In this configuration, network traffic is minimized by isolating data movement because the backup data might not even touch the regular network at all. It moves internally or via a direct connection.
Sounds very efficient. Limitation.
The limitation is that the backup device is dedicated to that one NAS head. This can limit centralized management and efficient sharing of expensive backup devices across your entire environment if you have multiple NAS systems.
Okay, so what if you want to share devices between NAS heads using NDMP?
That's where NDMP three-way comes into play. To avoid sending backup data over the production LAN between NAS devices, the recommendation is that a separate private backup network must be established between all NAS heads and the NAS head connected to the backup device.
A dedicated network just for NAS backup traffic.
Ideally, yes. This allows the NAS head that is connected to the shared backup device, acting like a storage node, to receive backup data directly from other NAS heads over this private network. This enables device sharing.
And control still happens over the public network.
Right. Metadata and control data still use the public network to talk to the main backup server, but the bulk backup traffic between NAS devices is offloaded onto that dedicated backup network.
So three-way is useful when you need to share backup devices among multiple NAS heads in a larger environment.
Exactly. It provides that sharing capability while still keeping the heavy data traffic off your primary production LAN. So we've talked about sources, processes, topologies. Let's talk about the destination. Where does all this backup data actually go? For decades, as you know, physical tapes were pretty much synonymous with backup.
Yeah, the classic computer tape reel or cartridge. They were the workhorse, right?
Absolutely. For many years, they were really the only practical option for storing large amounts of data, especially for long-term retention and off-site storage. But they have inherent characteristics. Tape drives are sequential or linear access devices.
Meaning you have to read or write data in order, like an old VCR tape. You can't just jump to the middle easily.
Precisely. To restore a specific file near the end of the tape, you often have to physically wind through all the data that came before it. Tape mounting, of course, is the physical process of inserting a cartridge into a drive, which also takes time.
What about trying to speed tapes up? I remember hearing about streaming.
Right. Tape drive streaming or multiple streaming was a technique to try and keep the drive busy. It writes data from multiple backup jobs, multiple streams, onto a single tape simultaneously.
Sounds more efficient for writing.
It improves media performance during backup, yes, but there's a significant disadvantage for restore. The backup data is interleaved on the tape. Bits of job A, bits of job B, bits of job A again. This significantly increases data recovery time because all the extra data from the other streams must be read and discarded just to piece together the single stream of data you actually want to restore. Makes targeted restores much slower and more complex.
So tape's main advantage was always cost.
Primarily, yes. They offer a low-cost solution per gigabyte of storage. And because they're portable, they are still primarily used for long-term off-site storage by many organizations. Take the tape off-site for disaster protection.
But the disadvantages seem pretty significant for modern needs.
They are numerous, yeah. That sequential data access translates directly to slower backup operations, but more critically, much slower recovery operations. Really impacts your RTO negatively.
And they wear out, right?
They do. The read-write head physically touches the tape surface, so the tape degrades or wears out after repeated use. They also have a shorter reliable shelf life compared to disk if not stored perfectly. They require a controlled environment, stable temperature, stable humidity for proper long-term preservation. Otherwise, the tape media itself can degrade.
Can moving them around?
That's another headache. Physical transportation adds to management overhead and increases the possibility of loss of tapes, which is a massive security and compliance risk if sensitive data goes missing.
You mentioned shoe shining earlier, too.
Ah, yes, the dreaded shoe shining effect. This happens when the data stream coming to the tape drive isn't fast or consistent enough to keep the tape moving smoothly forward. The tape drive ends up stopping, rewinding slightly, starting again, stopping, rewinding, constantly moving back and forth over the same spot.
Like shining a shoe.
Exactly. This rapid back and forth motion dramatically wears out both the tape media and the drive heads, shortening their lifespan and increasing the risk of errors and data corruption.
So given all these limitations,
And given the increasing availability of low-cost disk drives, the reality is that tapes are no longer a preferred choice as a primary backup destination for enterprise-class data centers. They've largely been relegated to secondary, archival, or off-site roles.
which brings us to disk drives, the performance and flexibility champions.
Pretty much. Disks are now the most popular storage medium for storing and accessing data, especially for performance-intensive online applications and increasingly for backup. Their key advantage is supporting rapid access to random data locations. Data can be written or retrieved quickly from anywhere on the disk platters, supporting many simultaneous users or applications.
No sequential access bottleneck.
None. They also offer large capacity and disk arrays, which combine multiple disks, provide increased capacity and enhanced performance, often using RAID technology for speed and redundancy.
And you mentioned these can be attached to the SAN.
Right. The trend towards low-cost, high-capacity disk drives has enabled large disk arrays to be attached to the SAN and used as backup devices, making them a fast, reliable primary backup target.
Disk for primary, tape for secondary offsite.
That's a very common tiered approach today. Balances speed and reliability with long-term, low-cost retention.
Okay, but what if you have a huge investment in your existing backup software? Maybe software that's been around for years and is designed purely around managing tape libraries. But you want the speed of disk. Are you stuck?
Great question. No, you're not stuck. This is where a really clever technology called virtual tape libraries, or VTLs, comes into play.
Virtual tape library, so it's not real tape.
Exactly. It's a brilliant concept. Disk drives are emulated and presented as tapes to the backup software. It's essentially a disk-based storage system that pretends to be a traditional physical tape library. It tricks your legacy backup software into thinking it's still sending data to tape cartridges in tape drives controlled by a robot.
But the data is actually going to much faster, more reliable disk drives underneath.
Precisely. It's a masterful illusion.
What's the main benefit of doing this? Why not just switch to disk-native backup software?
The core benefit, and it's huge for many large enterprises, is that VTL does not require any additional modules, configuration, or changes in the legacy backup software. It effectively preserves the organization's often significant investment in its existing backup software licenses, processes, and staff training. No need to rip and replace the whole backup application layer.
That's a massive win. It minimizes disruption.
Huge. And compared to physical tapes, virtual tapes running on disk offer better single-stream performance, better reliability, and random disk access characteristics. Both backup and restore operations are benefited from the disk's random access characteristics because they are online and provide faster backup and recovery. Your RTO improves dramatically.
And easier to manage too, I bet.
Much easier. VTL does not require the usual maintenance tasks associated with a physical tape drive, such as periodic cleaning and drive calibration. No physical tapes to handle, label, store, transport. They're also generally known for easy installation and administration because it is pre-configured by the manufacturer. Basically, plug it in, configure the virtual tapes and drives, point your backup software at it, and go.
So how does the emulation actually work?
Under the covers, a VTL uses standard disk drives as its backup media. But the clever part is the emulation software. This software maintains a database with a list of virtual tapes it's pretending exist. Each virtual tape is assigned storage space on a logical unit number, or LUN, presented by the underlying disk array.
So in the backup software says, mount tape XYZ in drive 1.
That robot mount command, which would normally trigger a physical robot arm to move a tape cartridge, is virtually performed by the VTL software. It just logically maps the requested virtual tape to a virtual drive, and it's almost instantaneous.
No waiting for a robot.
None. The load to ready time is much less. And unlike physical tapes, VTLs are not constrained by the sequential access and shoe-shining effect, because fundamentally it's all disk access. Even a command like rewind tape is also instantaneous.
Which means restores must be way faster.
That's the payoff. Restore operations, especially for specific files or smaller datasets, are nearly instantaneous compared to winding through a physical tape. Drastically improves your RTO.
So, okay, let me connect the dots here for you, the listener. VTL sounds like a really powerful bridge. It offers a way to get the best of both worlds, doesn't it?
It really does.
You get that familiar interface of tape library management that your existing backup software already understands and works with,
Preserving investment and processes.
combined with the superior performance, the reliability, the ease of use of modern disk storage underneath, all without having to rip and replace your entire backup system overnight.
It's a strategic move, a significant upgrade path that minimizes disruption while leveraging those prior investments. Very popular for exactly that reason.
Okay, we've talked targets. Now let's shift gears to efficiency. Because with the amount of data growing exponentially, just having fast targets isn't always enough. We need to be smarter about the data itself. And this is where data deduplication comes in, right?
Yeah.
You mentioned it earlier. It sounds like a game changer for modern backup.
It absolutely is. It's one of the most significant technologies to impact backup and storage efficiency in the last couple of decades. It directly addresses the explosion of data we're all seeing and that constant pressure on backup windows.
What's the core problem it solves? Redundancy.
Exactly. The problem of redundancy is enormous in traditional backup approaches. Most backup software historically didn't provide any inherent capability to prevent duplicate data from being backed up. Just think about it in your own environment. How many copies of the same Windows operating system files exist across all your servers? How many identical email attachments get sent to dozens or hundreds of people and then backed up individually from each mailbox?
A lot, I imagine.
A huge amount. With information growing exponentially and those relentless business demands for 247 application availability shrinking backup windows, traditional processes that back up a lot of duplicate data just aren't sustainable. It significantly increases the backup window size requirements, and it causes unnecessary consumption of resources such as storage space and network bandwidth. It's incredibly wasteful.
So what's the deduplication promise? How does it fix this?
The promise is simple yet incredibly powerful. Deduplication is the process of identifying and eliminating redundant data.
How does it actually work? Does it compare whole files?
Usually it works at a more granular level, often with data blocks or chunks. The system breaks the incoming data stream into small chunks. It calculates a unique identifier, like a hash or fingerprint for each chunk. It then checks if it has ever seen a chunk with that exact same identifier before.
And if it has?
If it's seen that identical chunk before, meaning it's duplicate data, the system discards the incoming duplicate chunk and instead just creates a pointer that refers back to the copy of that chunk it already stored previously.
So instead of storing the same chunk 100 times, you store it once and have 100 pointers saying, use that chunk over there.
Exactly. You store unique data blocks only once. The fundamental benefits are massive. It helps to reduce the storage requirement for backup, often achieving reduction ratios of 10.1, 20.1, or even higher, depending on the data type.
Wow, 10 or 20 times less storage needed.
Potentially, yes. It also helps shorten the backup window because less unique data actually needs to be transferred over the network and written to the target storage.
And less network traffic.
Right, it helps remove the network burden.
Yeah.
And as a bonus, because you're storing less data per backup, it helps to store more backups on the disk and retain the data on the disk for a longer time. You can keep more recovery points available online for faster restores.
Okay, that sounds amazing. How is it implemented? Where does this deduplication magic actually happen in the backup process?
Good question. There are two main approaches regarding where the deduplication occurs. First is source-based data deduplication.
Source-based, meaning on the client machine.
Exactly. As the name suggests, this approach eliminates redundant data at the source before it transmits to the backup device. So the backup client agent itself analyzes the data, identifies the unique chunks versus the duplicates, and only sends the unique chunks over the network to the storage node or backup target.
What are the advantages of doing it at the source?
The key advantages are profound, especially for network bandwidth. It dramatically reduces the amount of backup data sent over the network. This leads to a shorter backup window and requires less network bandwidth, huge for backing up over slow WAN links, for instance. Plus, you get a substantial reduction in the capacity required to store the backup images right from the start at the target.
Sounds great. Are there any considerations or downsides?
The main consideration is that doing the deduplication processing at the source increases the overhead on the backup client. The client's CPU and memory are used for analyzing data, calculating hashes, comparing chunks. This can impact the performance of the backup itself, making it take a bit longer locally, and potentially impact the performance of the primary application running on that client if resources are tight. It might also require specific backup software capabilities.
Okay, so source-based saves network and storage, but uses client resources. What's the alternative?
The alternative is target-based data deduplication. Here, the deduplication occurs at the backup device, the storage system receiving the backup data. This approach effectively offloads the backup client from the deduplication process. The
Okay.
client just sends its data normally.
So the heavy lifting happens on the backup storage appliance or server.
Correct. Now, within target base, there are actually two flavors based on when the dedupe happens at the target.
Oh, what are they?
You can have inline deduplication. This performs the deduplication during the backup stream before the data is actually written to the underlying disk storage on the target device.
So only unique data hits the final storage medium.
Right. It reduces the immediate storage capacity needed. However, it introduces overhead in the form of the time required to identify and remove duplication while the backup is running. So the backup stream itself might be a bit slower. Best for environments with a large backup window or less stringent backup performance needs.
Okay, inline happens during the write. What's the other type?
The other is post-process deduplication. Here, the incoming backup data is stored on the target device first, usually in a temporary landing zone on disk, and then deduplicated later as a separate background task after the backup job completes.
Ah, so get the backup done quickly first, then clean up the duplicates later.
Exactly. This is often suitable for environments with tighter backup windows because the initial backup operation finishes faster. The downside is it requires more storage capacity to store the backup images before they are deduplicated, needing that temporary holding space.
What's the general advantage of doing dedupe at the target, inline or post-process, versus the source?
The main advantage often cited is that target-based deduplication typically does not require any changes in the existing backup software running on the clients. The intelligence is in the target device.
Makes deployment easier sometimes.
Can do. However, the key point to remember with target-based is that all the backup data need to be transferred over the network from the client before deduplication can happen at the target.
So it doesn't save network bandwidth like source-based does.
Correct. Target-based primarily saves storage space, while source-based saves both network bandwidth and storage space, but at the cost of client overhead. Trade-offs again.
This sounds like it has huge implications for remote offices. You mentioned WAN links earlier.
Absolutely. This is a really big one for distributed organizations. Historically, backing up remote or branch offices, robo, was a total nightmare. You had manual tapes being swapped by non-IT staff, unreliable slow WAN connections, high costs for dedicated backup links. It was often inconsistent and risky.
Yeah, I can imagine.
Now, as the material highlights, disk-based backup solutions along with source-based deduplication eliminate the challenges associated with centrally backing up remote office data.
Because the source dedupe shrinks the data before it hits that slow WAN link.
Precisely.
Yeah.
The massive reduction in data volume from source-based dedupe often allows organizations to perform robo backups using the existing network infrastructure they already have. No need for expensive dedicated lines just for backup. It allows them to centrally manage and automate backups for all remote sites, improving consistency and reliability while significantly reducing the backup window even over slower WAN connections.
That's a massive leap forward. Saves cost, improves protection for those distributed workforces.
Huge improvement in operational efficiency and data security for robo environments. Deduplication really enabled that shift. Okay, another major transformation in IT infrastructure that profoundly impacted backup strategies is, of course, virtualization.
Right. Moving from physical servers to virtual machines running on hypervisors like VMware or Hyper-V, that changed everything.
It really did. Virtualization has transformed data centers, abstracting physical resources, compute, storage, networking into logical pools. Immense benefits in efficiency, agility, consolidation. But backup strategies absolutely had to evolve significantly to keep pace with this new paradigm. The traditional physical server ways of doing backup just weren't optimal or sometimes even sufficient in a virtual world.
Why not? What was the challenge?
Well, the imperative is clear. In a virtualized environment, it is imperative to back up the virtual machine data that includes the guest operating system inside the VM, the application data, and its configuration to prevent its loss or corruption. Virtual machines, VMs, are just as susceptible to failures, human error, malware, or cyber attacks as physical servers. Maybe even more so in some ways due to the shared underlying infrastructure. Losing a single critical VM could mean losing an entire application environment.
So how did people initially try to back up VMs using traditional methods? And why did those methods fall short?
One common early approach was simply installing a traditional backup agent inside the VM itself. You treat the virtual machine just like it was a physical server. To the agent running inside, the VM appears as a physical server. It would back up the files and application data it could see within the guest OS.
Sounds okay. What's the downside?
The significant downside is that this in-guest agent does not capture VM files, meaning that the files that actually define the virtual machine itself at the hypervisor level. Things like the virtual BIOS file, the VM swap file, logs, and critically, the VM's hardware configuration files.
So you back up the data inside the VM, but not the VM container itself.
Exactly. Which means, as the material points out, for a VM restore, a user needs to manually recreate the VM, set up a new empty virtual machine shell with the right CPU, memory, network settings, and then restore data onto it using the agent.
That sounds like a lot of manual work. Slows down recovery dramatically.
Hugely extends the RTO, yeah. Very inefficient for rapid recovery.
What was the other traditional approach?
The other was installing the backup agent on the hypervisor itself, the server hosting the VMs, like the ESI host or Hyper-V host. From the hypervisor's perspective, the VMs appear as a set of files to the agent. The virtual disk files, VMDKs, VHDs, configuration files, etc. This allows for backup of the entire VM file structure.
That sounds better. Simpler, too, maybe. Fewer agents to manage.
Simpler in terms of agent count, yes, but the major drawback here is that running the backup agent on the hypervisor can cause high CPU utilization on the server being backed up. The hypervisor is busy running potentially dozens of production VMs. Adding the load of backup processing directly on top can significantly impact the performance of all those live VMs.
So you'd have to schedule these backups carefully during very quiet, idle times.
Pretty much, yeah. To avoid impacting production performance, still not ideal.
So these traditional methods had real limitations. How did the industry solve this for virtual environments? What's the preferred approach now?
This led to the development and widespread adoption of image-based backup. This is truly the preferred, standard approach for VM backup in the modern virtualized world.
Image-based backup, how does that work? Does it still use an agent?
It typically works without installing a traditional agent inside every single VM. Instead, it operates at the hypervisor level and essentially takes a snapshot of the VM.
A snapshot, like freezing the VM in time.
Exactly. Think of it like pressing pause on a video game and instantly copying the entire game state at that precise moment. The hypervisor has built-in mechanisms to create these point-in-time snapshots of a running VM's disk and memory state very quickly.
What exactly gets captured in that snapshot image?
It creates a copy of the guest OS and all the data associated with it, snapshot of VM disk files, including the VM state and application configurations. Basically, the entire VM as it existed at that instant OS apps data settings is saved as a single image file or set of files.
Okay, so you get the whole VM.
Yeah.
Where does the backup processing happen then, if not on the hypervisor?
This is the clever part. This snapshot image is then typically mounted on a separate proxy server, which acts as the backup client for this operation. The backup software running on the proxy server reads the data from the mounted snapshot and backs up these image files normally to the backup target.
So the hard work of reading the data and sending it to the backup storage is offloaded from the production hypervisor.
Precisely. That's the key benefit. It effectively offloads the backup processing from the hypervisor and transfers the load onto the proxy server, thereby reducing the impact to VMs running on the hypervisor. Keeps production running smoothly.
And the other huge benefit must be recovery.
Absolutely critical. Image-based backup enables quick restoration of a VM. Because you backed up the entire VM image, you can restore that entire image rapidly. You can bring the whole virtual machine back online, quickly operating system, applications, data, configurations, all exactly as it was at the time of the snapshot. Massively faster RTO compared to manually rebuilding a VM.
That sounds much, much better. So image-based is the way to go for VMs.
Generally, yes. It's become the standard for effective VM protection.
And how does deduplication fit into this virtualized world? Does it work well with VM images?
It works exceptionally well. This is where deduplication often provides enhanced value. Its role becomes even more significant and impactful in virtualized environments. Deduplication is significantly effective in these settings, especially, as the material notes, when VMs with similar configurations are deployed in a data center.
Like having lots of VMs running the same version of Windows.
Mm.
Or maybe many virtual desktops based on the same template.
Exactly those scenarios. In such cases, a large percentage of the underlying data blocks within those VM image files are absolutely identical across many, many VMs. Think of all the common OS files, application binaries. Deduplication shines here. It allows for massive storage savings by only storing those common unique subfile data blocks once, even if they appear in hundreds of different VM
So
backups.
you get huge dedupe ratios.
Often, yes, dramatically reducing the amount of backup storage required and further shortening backup windows, even when dealing with large VM image files. It's a perfect match for virtual environments.
Okay, fantastic. We've covered a ton of ground. The why, the what, the how, the topologies, the targets, the key technologies like dedupe and image-based backup. Now, let's put all this knowledge to the test. Let's apply it. Imagine you and I are advising a telecom company facing a pretty common, yet absolutely critical, backup challenge. This is where we bring everything we've learned together into a practical, real-world solution, like we're instructors guiding a student through a problem based on this material.
Sounds good. Let's set the scene. What's the business profile of this company?
Okay, so it's a telecom company, a major player in mobile wireless services. They're global, with about 5,000 employees worldwide and operations spanning 7 regional offices. Financially, the good news is they're doing well. But, and this is key, they're constantly feeling competitive pressure.
The telecom space. Fiercely competitive. Margins can be tight. Customer churn is a constant threat.
Exactly. So what does that mean for their IT? It means their infrastructure needs to be highly fault-tolerant, super reliable, capable of continuous operation.
Because in an industry where customers expect constant connectivity calls always going through, data always flowing, zero interruptions, downtime is just completely unacceptable. It directly impacts customers and revenue.
Right. Now, let's look at their current configuration and challenges, specifically focusing on their data protection strategy based on the scenario provided.
Okay, what's their setup?
The biggest issue staring us in the face is their primary reliance on tape. The company uses tape as their primary backup storage media for their applications.
Tape as primary. Okay, that's a flag already in today's world for critical apps. What's their schedule?
Their backup schedule is pretty standard, actually. They do a full backup on every Sunday and incremental backups on the remaining days of the week.
Full plus incrementals.
Yeah.
Common, as we discussed, saves space during the week compared to daily fulls.
But here's the kicker. The critical pain point. The one that immediately jumps out and, frankly, screams for attention in a telecom environment.
Let me guess. Involves downtime.
You got it. Their database has to be shut down during the backup process.
Ouch. Shutting down a critical database for backup in a telecom company. Wow! That is a massive red flag. A huge operational liability. Hashtag PP. Unpacking the challenges.
Right, so let's unpack those challenges properly. That database shutdown is the elephant in the room, isn't it? For a company under intense competitive pressure, operating in a 247 industry like telecommunications, forcing a database shutdown every night for backup,
Right.
that's just not sustainable, surely.
It's completely unsustainable and incredibly risky. For a telecom company operating in that on-demand world we talked about, where every second of service availability translates directly to revenue, customer satisfaction, brand reputation, requiring a database shutdown for backup is an unthinkable operational liability. It directly conflicts with their core business need for 24/7 availability, and it incurs a potentially staggering cost of unavailability.
How bad could it be?
In industries like telecommunications or financial services, that cost can genuinely run into millions of dollars per hour of downtime.
Millions per hour. Wow.
Think about it. Millions of subscribers potentially unable to make calls, send messages, use mobile data, access account services, all because a critical database is offline for hours every single night just to run a backup. Even if it's a planned outage, it directly impacts their ability to serve customers, maintain their competitive edge, maybe even meet contractual service level agreements, SLAs. It fundamentally undermines their entire business model.
And the fact that they're relying on tape as the primary target just compounds the problem, doesn't it?
Yeah.
It's not just the shutdown itself. The recovery side is impacted, too.
Absolutely. Tape adds its own significant set of problems, especially when combined with that painful database shutdown and the incremental backup strategy they're using. Tape's inherent sequential access means slower backup operations to begin with, potentially lengthening that already painful downtime window. But more critically, it means significantly slower recovery times if something goes wrong. If that critical database ever needs to be restored, relying on tape for an incremental backup strategy means that multi-step, potentially manual, and definitely time-consuming restoration process we detailed earlier.
Restore the full from Sunday, then apply Monday's incremental, then Tuesdays, then Wednesdays, all from tape.
Exactly, which inherently extends the window where that critical database is offline after an incident.
Yeah.
It blows out their recovery time objective, RTO. Plus, you have all the other tape issues. The wear and tear on physical media, the significant physical management overhead storing, rotating, transporting tapes offsite, which adds operational burden, increases the chance of human error, and elevates the risk of data loss or corruption if a tape fails or gets lost.
So the current approach database shutdown, primary backup to tape, using incrementals, it's like a perfect storm of inefficiency and risk for a company like this.
It really is. It creates a fragile, slow, inefficient, and highly risky data protection strategy, completely misaligned with their scale, their industry, and their operational demands. It directly increases their RTO for critical data recovery, making them incredibly vulnerable in any kind of outage scenario.
Okay, so the problems are clear, and they're serious. Given everything we've unpacked in our deep dive, the criticality of that database, the huge operational cost of downtime, the inherent limitations of their tape-based incremental approach, how do we advise this telecom company? How do we guide them from this problematic current state to a resilient, modern backup solution? And critically, let's focus on leveraging the specific technologies and concepts discussed within our backup module material to directly address their pain points. We need to propose solutions drawn from what we've learned.
Right. Step one has to be addressing the most pressing issue, that database shutdown. For a 247 telecom operation, this is job number one. It's simply unacceptable. Now, and it's a reasonable assumption in a modern data center, if this critical database is hosted on a virtual machine,
Which is very likely these days.
very likely, then the image-based backup approach we discussed becomes the absolute primary solution drawn directly from this module. This can revolutionize their current process.
How specifically does image-based backup solve the shutdown problem?
By taking a snapshot of the entire VM at the hypervisor level, we capture the whole VM state, guest OS, application configurations, and all the data at a specific point in time without requiring a prolonged shutdown of the database inside. The actual backup processing, reading the data from that snapshot, is then completely offloaded. As we discussed, it happens by mounting the snapshot image onto a separate proxy server, which acts as the backup client. This completely isolates the production hypervisor and, more importantly, the live database from the resource impact of the backup process itself.
So the database keeps running, serving customers, while the backup happens from the snapshot in the background.
Essentially, yes. It dramatically reduces or potentially even completely eliminates the application downtime required during the backup window. This directly aligns with their crucial 24/7 availability requirement.
It tackles that painful database has to be shut down problem head-on, transforms a massive liability into, well, a non-event from an operational perspective.
Exactly. That's solution number one, leveraging image-based backup for VMs.
Okay, that's a huge strategic win right there. Allows the business to operate continuously. Now, beyond the snapshotting for VMs, the move away from tape as the primary target seems equally non-negotiable for performance, reliability, and just simplifying management in a modern enterprise.
Absolutely. That's solution number two, optimizing the backup target. Shifting from physical tapes to disk-based backup solutions offers immediate and substantial improvements right across the board. As we know, disk provides those random access characteristics. That means much faster backup operations, yes, but even more critically, significantly faster recovery operations.
Improving their RTO drastically.
Massively. Even if some very brief application-level pause or quiescing is still needed to ensure perfect consistency during the snapshot for certain highly transactional databases, the overall backup window and, more importantly, the restore time will be drastically reduced compared to managing sequential tapes.
And would a virtual tape library, VTL, be a good option here?
It could be a very attractive option, yes, especially if they have significant investments in their current tape-aware backup software or deeply ingrained tape-based operational processes. VTLs, as we discussed, allow the organization to gain all the performance and reliability benefits of using disk as the target medium,
while preserving their investment in that existing tape-aware backup software.
Exactly. It acts as that bridge technology, offering modern disk capabilities behind a familiar tape interface. It makes the transition much smoother, less risky, and potentially leverages existing skills.
So shift primary backups to disk, maybe via a VTL. Keep tapes for long-term offsite, perhaps?
That would be a very sound, modern, tiered strategy. Disk for speed and operational recovery, tape for cheap, long-term archival, and offsite DR.
Okay, so image-based backup for the VM, disk VTL for the target. What's the third key improvement we can recommend based on our deep dive efficiency, right?
Efficiency is key, especially for an organization of this size. That brings us to solution number 3. Boosting efficiency with data deduplication.
For a global company with 5,000 employees, 7 regional offices, they must have a ton of redundant data across their systems. Dedupe seems essential.
It's almost certainly essential for optimizing cost and performance at this scale, yes. Implementing data deduplication will further shorten their backup windows by significantly reducing the sheer volume of data that needs to be physically stored and, potentially, transferred over networks.
And given the presence of those regional offices, which type of dedupe would be most beneficial?
Given they have multiple regional offices likely connected via WAN links back to a central data center or maybe regional hubs, source-based deduplication applied directly at each office location would likely be incredibly beneficial here.
Why source-based specifically for the remote offices?
Because it dramatically reduces the network bandwidth required to send backup data from those regional offices over the potentially slower, more expensive WAN links to a central backup repository.
Shrinks the data before it hits the WAN.
Exactly. It optimizes their existing WAN infrastructure usage. This means less data to transmit, less congestion, faster remote backups, and less storage required at the central backup repository. It further minimizes operational impact and the overall cost of their data protection strategy across the entire distributed enterprise.
Allows them to centrally manage and automate backups across all those sites much more effectively.
Precisely. While source-based dedupe does add a bit of processing overhead to the clients in those remote offices, the network and central storage savings are typically well worth it for an organization of this scale and distribution.
Okay, let me try and connect all the dots for this telecom company based on our discussion. By adopting image-based backup, assuming the critical DB is virtualized, to eliminate the shutdown.
Step 1.
By leveraging disk-based solutions, possibly VTL, as the primary backup target for speed and reliability.
Step 2.
And by implementing robust data deduplication, especially source-based for their regional offices, to maximize efficiency.
Step 3.
This telecom company can fundamentally transform its backup strategy. It moves from being this disruptive, high-risk, slow, manual chore
Into a streamlined, highly available, automated process.
a process that not only protects their critical data far more effectively, but actively supports their competitive business demands for 247 operations and agility. This isn't just an IT fix, it's a strategic enabler.
Precisely. These integrated strategies, all drawn from the core concepts we've explored, ensure fault tolerance and continuous access to critical information. It turns what was once a significant operational headache and potential cost center into a true enabler of business continuity and operational agility. It allows them to focus on their core business, providing telecom services, knowing their foundational data is rock solid, resilient, and protected against the challenges of today's always-on world. The investment pays dividends in reduced risk, improved efficiency, and sustained competitiveness. Hashtag IV final provocation. You know, our deep dive today really revealed something important. It showed how understanding these foundational backup concepts, things like RPO, RTO, the different backup types, and combining them with modern technologies like disk-based systems, intelligent deduplication, and especially virtualization-aware techniques like image-based snapshots. How that combination can truly transform a company's entire approach to data protection. It elevates backup from just making a copy, just ticking a box, to something far more strategic. It becomes about ensuring uninterrupted business operations, maintaining that competitive edge, and genuinely thriving in this on-demand world where data availability is absolutely paramount.
That's a great summary. So the final thought, the provocation for you, our listener, as you consider your own information landscape, whether that's for your business or even just your important personal digital life, ask yourself this. Is your current backup strategy merely a safety net? Is it just a reactive measure you hope you'll never need? Or is it something more? Is it an active enabler of your business continuity, your operational agility, allowing you to innovate and operate with confidence? What one small change, perhaps inspired by something we discussed today, could you implement to start turning your backup routine from a chore into a genuine strategic advantage? Ensuring your critical data is always available, always protected, and always ready to serve your mission, whatever that might be.